Okay, we are going to try find the probability of a single event. I thought we just did that already. Now, why are the Monopoly pieces going by? I wonder if this is a subtle clue. So we're going to be looking at the probability of a single event, which is what we did in the first lesson. But we're going to see that this single event is a little more complicated to figure out. And those are the classic Monopoly pieces. Again, I grew up in the board game era where that was our fun to do with friends and family. So we're still looking at a single event, but the sample space is a little more tricky. Okay, so let's revisit our penny here real quick. Okay, notice instead of saying, hey, there are two outcomes, I'm referring to it as being the sample space, right? So the sample space is there's a heads and there's a tails. And so I might even say the size of the sample space is 2, right? Previous lessons we just said, hey, there are 2 different things that could happen. Now I'm introducing a little bit more of the vocabulary. We'll call it the sample space, and then we'll call the size of the sample space. Now, what if for a single event, I decide to toss a penny, a dime, and a quarter up in the air? Woo, they'll go flying up there and they land. Notice I'm calling this a single event. I know there are 3 different coins I'm throwing, but I'm just going to toss them all and say, hey, this is just one event that's happening. So, what could happen? Well, let's go in order. I know there could be 3 heads and no tails. I know there could be 2 heads and 1 tails. I know there could be 1 heads and 2 tails. We could have 0 heads and 3 tails. Now, if you think it sounds kind of funny to say 1 heads, remember, just when we call the coin, we either say heads or tails, and so I know 1 doesn't sound like it should be plural, but heads is what we call the outcome. Now, are all those really equally likely to happen, though? Right? If I want the probability of 3 heads versus 2 heads, I really need to know what the sample space looks like. And I'm going to show 2 different methods of finding the sample space. I'll do one with the coins here, and we'll do a different one with dice in a little bit. So with the coins, I'm going to use a tree method, and the tree diagram is real useful when you have like 3 or 4 different things that happen in your event. So let's start and say, okay, first coin's a penny, right? The penny, of course, could land on heads. The penny could land on tails. Okay, now, the next coin was a dime. So if the penny landed on heads, the dime could also land on heads, or the dime could land on tails. Now, if the penny landed on tails, the dime could have landed on heads, the dime could have landed on tails. Oh, now we got to look at each of these situations with the quarter. So again, heads penny followed by heads dime could be followed by heads quarter, or it could be followed by tails quarter. Same thing with his next branch. Same thing with the next branch. And same thing with that last branch. Oh, so it actually looks like in the sample space, our size is 8, right? There's actually 8 different ends on the tree diagram. The first end has 3 heads and no tails. The next one has 2 heads and 1 tails. The next one also has 2 heads and 1 tails, but notice they're different, right? On the first one, it was the penny and the dime that were heads. On this one, it's the penny and the quarter that are heads. Now there's only 1 heads. Ooh, 2 heads again. But notice this is a new outcome because it's the dime and the quarter that are heads. That's different than what we had on the other ones. Again, only one of them is heads here, but it's different because it's the dime instead of the penny. Only one heads here, and again, this is different because it's only the quarter that's the heads. And then, of course, there are no heads here, right? So that's the sample space. The size of the sample space is 8. So if I do the probability, the number of outcomes is 8. Let's get a little bit of room here. So that's the sample space. The size of the sample space is 8. That means the number of possible outcomes is 8. So the probability that for my single event, I throw the coins in the air and all 3 of them are heads, well, there's only one way that can happen. 1 out of 8. Or if I throw all 3 coins up in the air at once and they all come down and land on the ground, the probability that exactly 2 of them are heads, 3 different ways it can happen, 3 out of 8. The probability that exactly 1 of those coins is heads. Hey, 3 ways that can happen. Probability is 3 out of 8. The probability that none of them are heads, that everything is tails. Well, 1 chance out of 8 that will happen. So there are the probabilities. Okay, so let's get to those dice, and this kind of explains where those Monopoly pieces were coming from. Let's pretend I'm playing Monopoly, and I really want to roll a 9, because I want to land on the short line railroad. Right? I already own the other 3 railroads, and I get to collect $100 rent if someone lands on one of them right now. But if I had all 4 railroads, the rent actually goes up to $200. Right? So I really want to roll a 9. Now, Monopoly, back in the good old days when we had board games and you'd sit down with your siblings or friends or neighbors or family, you roll a pair of dice. Now again, if these are standard 6-sided dice, each die might result with a 1, 2, 3, 4, 5, or 6. And again, that's what the net would look like, right? If you imagine these dice were made out of paper and you could cut them and unfold them, right? You've got a 1, 2, 3, 4, 5, and 6. That's the different sides. And obviously there's no number 9, so when we talk about rolling dice and getting a 9, we're talking about the sum of the 2 dice. Right? So I need a sum of 9. So let's find the sample space, and then let's find the probability of rolling a 9. Now, I'm going to use 2 different colored dice. One die is green, one die is blue. And instead of making a tree diagram, I'm going to use an area model. Area models are quite useful if there's only 2 different objects in our event. If there had been 3 dice, I would really be forced to use a tree diagram, right? Area model would not work so well. Area model works fantastically well, though, if there are just 2 different objects involved in my event, right? The green die could result in a 1, 2, 3, 4, 5, or 6. The blue die could result in a 1, 2, 3, 4, 5, or 6. Okay, so what's the sum? Well, first of all, before I get that far, right, the size of the sample space is 36, right? 6 times 6 is 36. There's 36 totals I've got to figure out. So 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4, etc. All the way up to 1 plus 6 is 7. Then I'm going to do 2 plus 1 is 3. Now, this is why I use different colored dice. Notice that one of those 3s is created with a green 2 and a blue 1. But now I just got a 3 that's created with a blue 2 and a green 1, right? Those are different events. A lot of students, if I just put a pair of dice up where they're the same color, it's a little trickier to understand what's happening there. Okay, let's finish this row. Again, I'm adding the blue 2 to each of those green numbers. Now I can do that with the 3. Okay, 4 plus 1 is 5, 4 plus 2 is 6, 4 plus 3 is 7, 4 plus 4 is 8, 4 plus 5 is 9, 4 plus 6 is 10. Alright, let's get the next row up here. And the final row. Right, so those are the 36 possible results, right? So the size of the sample space is 36. Now, I want to know the probability of rolling a 9. Well, it looks like there are 4 different ways I can roll a 9. Right? The green die could be a 6 and the blue could be a 3. Or I could have green 5, blue 4. Or green 4, blue 5. Or green 3, blue 6. So 4 different ways of getting a 9. 36 is the size of the sample space, right? 36 possible outcomes. So the probability of me rolling a 9, well, 4 over 36 reduces to 1/9. And there is my answer. All right, so again, let's be surprised that it says worksheet. My goodness, what a shock that the word is worksheet. Nice little mountain sunset. Or it could be sunrise. Can't really tell if it's sunrise or sunset. I just know it's either early in the day or late in the day. And the word worksheet will vanish. And we're off to go work on a worksheet here.